Okay, now let's go over the second part of the integral, which was 4 over x squared plus 2 squared dx. So we see there's a constant in the numerator, which means that we're probably going to be doing not u sub because nothing would really cancel out. And then we see on the denominator here that it's x squared plus 2, which is an x squared plus a squared format, which means that we would be doing tan trig integral. So we can see that 2 is equals to a squared, so that means that a equals to root 2. So we would get x equals root 2 tan theta. This is wrong, by the way. The tan theta should not be in the root. And if we integrate that, we would get dx equals root 2 secant squared theta. Now just plug in the root 2 tan theta as the x, as we did here, and also plug in root 2 secant squared theta as your dx. And if we simplify that and multiply it all out, we would get 4 root 2 secant squared theta over 2 tan squared theta plus 2 squared d theta. Now you can see there's a 2 here and here, so we would be able to do, factor the 2 out. So we get 2 times tan squared theta plus 1 all squared, which means that we can pull out a 4 as we did here. So the 4 on the numerator and the denominator would cancel out, and the root 2 can be pulled out into the front. And we can see that the tan squared theta plus 1 is the same thing as secant squared according to trig identities. So you would get root 2 integral secant squared theta over secant squared theta squared d theta.